So this video is going to go over some of the information that we went over at the August 2019 focus on the reading brain. So a little bit of a disclaimer here at the beginning. The pictures that we use, the labeling that we use are very loose representations of what happens in the brain during reading. And so the whole idea is that we're just giving teachers a basic understanding of what's going on in the brain and what the instructional implications might be. We are not going for accuracy for a biology kind of situation. The brain diagram is from a coloring book. So if you're looking at this to get like a super accurate anatomical idea of what's happening in the brain, this is not the video for you. So this is just a very general kind of thing. So I just wanted to say that at the beginning. So the first thing we're going to talk about and think about is this. Is reading natural for the human brain? And spoiler alert, the answer is no. So humans have been around for a long time, and we started as a group to have basic language and communication about 500,000 years ago. And then grammatical language started to happen for us about 100,000 years ago, but it was oral. And then about 10,000 years ago, we started to have reading and writing. And so reading is not a natural thing, and the brain sort of hijacks pieces developed for other kinds of things in order to have us become readers and to be able to interpret what we see. So for example, our eyes and brain work together to do face recognition. Well, the brain uses some of that same circuitry that for face recognition to recognize letters, but the brain did not evolve in for letters. So it's sort of like the brain MacGyvered a bunch of different parts together to be able to process written language. Speaking is natural. Babies will learn a language without any explicit instruction. They just learn from being around us. And if you've ever lived with a baby, had little kids around you, you'll see that they really quickly will pick up what they hear and start saying the same words. And in some cases, this is a beautiful and wonderful thing. And if you accidentally say a cuss word, you know for a fact they are going to repeat it. The next time that they see your mother-in-law, they pick it up real quick. So speaking and hearing are very natural things for human beings. Reading is not natural. So our brains need instruction to learn how to read. That it's so important to read to kids, but they're going to need a little bit more than only, being read to in order to pick up and crack the code of reading. So the objectives of this little video are to help you understand how the reading circuit is formed, to understand how the parts of the brain work together to read, and to understand the instructional implications of this knowledge. So this is our little coloring book page, and at the live presentation, the participants did have a handout, and we had them annotate. And if you would like to do that, if you want to pause, you can Google search for brain diagram or brain coloring book or something and kind of print it. You could draw yourself a little brain if you wanted to. It doesn't have to have all the little beautiful swirls. Or if you want to just listen, you can do that as well. But I'm going to keep going now. So the brain is divided into parts, and you do not have to memorize the names of these parts. There will not be a quiz in your PLC or at a focus meeting, but it's good to know, just to understand that there are parts and that each part has a little different role. So I'm just going to call them the front, the back, and the sides for the purposes of this video. So if you want to sketch or take notes, feel free, but you don't have to. So the part of the brain where the brain processes letter shapes and other things you see is kind of the bottom back here. So it was blue on that first diagram. And so when you see things, the information starts down here and your brain starts to process it. When you hear sound, that's processed sort of in the top middle and the bottom middle. And then once you've seen it and you've heard it, the front part sort of takes over. And I put a light bulb here because that is where all the really heavy lifting and thinking happens. It gets kind of more complex from the bottom back and going all the way up to the front. The thinking processes get more and more complex. And I want you to think about it like this. At the training, I had everybody rub their between their eyebrows and the front of their head. So if you ever get super, super stressed out and you're trying to think really, really, really hard about a problem, a lot of times we will rub that part of our forehead, and I want you to make that connection. Like your brain is doing super deep thinking and you're kind of touching the part of your forehead that would be near the part of your brain that is doing that thinking. And then this little piece kind of down at this curve, that's where you generate speech. So you see things, you hear things, you think about them very complexly, and then you're ready to output your own thinking into the world. So this is something that I put together with some very useful and simple tools. My husband made fun of my drawing or my little thing here, but it gets the job done. So here we go. So if you're reading Alice in Wonderland, your eyes will see the words and that will kind of bounce in at the back of your brain. And then the part of your brain that thinks about sounds will be activated. Even if you don't hear that being read out loud, that part of your brain still lights up because your brain has connected the sounds that the letters are associated with, like V makes a V sound, or S can make a S sound or a Z sound. That part of your brain lights up even if you're not hearing it being read aloud. And then to think about the meaning and process the meaning, this part of your brain, that front piece of your brain lights up. And then that when you connect the reading circuit with output, with speaking, with writing, this part of your brain lights up. And so that's super important because if you're trying to have a kid memorize something, like the meaning of an academic vocabulary word, or the way something is spelled, or a fact that you want them to retain, if you don't complete the circuit by having them speak that information and write that information, it doesn't get stored in the long-term memory down here. There's a physical place where words and things and ideas and knowledge is stored in the brain, and it's right about here. And if you want to lock that information in, kids have to speak and they have to write. And so if you don't have them do that, it's sort of like running a blender, but with the lid off, and that information is going to spill out. So writing and speaking helps lock the information in. It's like putting the lid on the blender so everything stays where it's supposed to stay. And so that is my beautiful drawing. So another thing to think about is that neurons that fire together wire together. And so neurons are all these circuits there's all this circuitry in your brain. And when you're a kid, I want you to think about it. And you're in kindergarten, first grade, preschool, what happens is teachers will say, okay, A makes the A sound. And then you learn to trace the A with your finger and you write the A, you're learning handwriting. Well, the physical act of writing triggers the brain to pay closer attention to the task at hand. So if your brain is kind of like, meh, I'm tired, I'm turned off, just the act of physically putting a pencil or pen or marker in your hand and putting it to paper actually turns the brain on and says, wake up, brain, we need you to think more closely about what's going on here. So if you're having trouble with kids not retaining what they're reading, like maybe you're having them read and then having them answer multiple choice questions, and they're just not retaining it, one thing you could do is ask them to write about what they're reading as they go, and that actually makes their brain focus better on what they're reading, and then it makes them think harder about it, and they're more likely to comprehend what they're reading, and they're more likely to pay closer attention. It's really interesting. I just went over some instructional implications. And so you do not have an opportunity right now to turn and talk with your friends, but instructionally, some of the things we recommend is just what I just said. Really having kids write about what they read. When they make a prediction before they read, have them jot a sentence quickly. Hey, I think the story is going to be about whatever because whatever the reason is. Maybe they previewed the title, maybe they looked at subheadings, maybe they looked at pictures to make that prediction. But just the physical act of having that pencil in the hand and writing is going to help them retain what they read better. And then when you think about having them retain academic vocabulary or something you want them to remember, having them speak about it and then write about it is going to help them keep it in memory. Because I know like one thing we teach all the time, a million times, is figurative language. And teachers always get mad and say, I've taught metaphor a billion times. And the thing is, if you're teaching metaphor a billion times, but you're not having them write about it and write their own metaphors, it's not going to stick, because it's like teaching with that, the blender with the lid off of it, to use figurative language. If you want that instruction to stick, they have to speak and they have to write. And those are the instructional implications that we talked about in the training. So I hope that you enjoyed this video, and we'll see you hopefully in person soon.